if I'm taking a limit as x approaches 1, of course, my plan A is always to use direct substitution. I never want to forget that. To give us 3 times 1 plus 3 over 1 minus 1, which gives us 6 over 0. Remember, when we got 0 over 0, that was an indeterminate form, and that told us right away that we were dealing with a whole. So we tried to find a plan B, cancel, and then we worked around the whole that way. Notice, if we get a number over 0, that tells us we're dealing with a vertical asymptote. So if we're taking, here we've got a two-sided limit at a vertical asymptote, of course, the limit will not exist. A two-sided limit at a vertical asymptote will not exist. By the way, the graph of this looks like this. Looks something like this. Shooting this way and shooting this way. You can see that as x approaches 1, from the left, our graph is going to negative infinity, and for the right, it's going to positive infinity. We have this infinite discontinuity here, so there's no trend in y. The limit, the two-side limit, does not exist. The first thing I want to try with any limit is direct substitution. Note that this is a one-sided limit. It's x approaches 1 from the left. Well, if the function is continuous, or if the function is, we're taking the limit at a whole, most likely the left side limit is going to equal the right side limit. So even though this is a limit from the left, if I substitute here, I'll get 3 times 1 minus 3, because x is still heading towards 1 over 1 squared minus 1, which gives us 0 over 0. That tells us we're taking the limit at a whole. So can we do our tried and true method, which would be to try to factor and cancel, factor the numerator, difference of perfect squares in the denominator, cancel. Of course, my whole, if I do x minus 1 equals 0, so x equals 1 is my whole, the x coordinate of my whole. So my surviving function is 3 over x plus 1. Now I can take the limit as x approaches 1 of this surviving function. The only thing different than everything we've done so far is that this was a one-sided limit. I'm still just going to use direct substitution. Why? Because it's not a vertical asymptote, right? It's not a vertical asymptote. I didn't get a number over 0. So the vertical asymptote is found at x equals negative 1, because I can take my denominator and set it equals 0. But I'm taking the limit at x equals 1, which is a whole. And remember, what we're going to do when it's a whole is just substitute into the surviving function. Contrast that last example with this one-sided limit. Note, this is a one-sided limit. And when I use direct substitution, I get 7 over 0, which tells us we're taking the limit at a vertical asymptote. So what we're going to do is we're going to go a little bit to the left of x equals 1. So a value we're going to put in would be like 0.999. Do you actually have to do the math? No. It's going to be a positive over 0.999 minus 1 is a negative, which will mean that our graph is going towards negative infinity. And in fact, you're not going to have to do this, but this is what the graph looks like. And you can see that as x approaches, what are we doing here? Let's just understand. As x approaches 1 from the left, that little negative there means from the left, y is going off the charts negative. If you're trying to find a limit, a one-sided limit at a vertical asymptote, then plug in a value very close to the value you want, but in this case, a little bit less. This is when we use the technique, when we're taking a one-sided limit at a vertical asymptote. What if I said, what is the limit as x approaches 1 of f of x? Notice this is the two-sided limit. This is the one that does not exist because we're asking, is there a trend as we pinch in on x equals 1 from both sides? But we can find the one-sided limit by making this substitution. Note that if I use direct substitution in here, I'm going to get 8 times 5 is 40, minus 1 is 39, over 5 minus 5 is 0. That tells me right away I'm taking the limit at a vertical asymptote. So it's 5, you notice this is a one-sided limit. It's 5, but a little bit more. So why not use 5.001? 8 times 5.001 minus 1 over 5 minus 5.001. When do I use this technique? I recognize I'm looking at a vertical asymptote and I'm taking a one-sided limit at the vertical asymptote. Well, this is going to give me a positive number divided by a negative number. So our graph is going to be heading towards negative infinity. And in fact, when we look at this graph, and I'm not expecting you to do this, but we're going to have something that looks like this. Our graph goes down, 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 and up, up, up. So as x approaches 5 from the right, we can see that our graph goes down, down, down. A one-sided limit at a vertical asymptote, if this is a vertical asymptote, our graph is always going to be either going up and down, up towards positive infinity, or down towards negative infinity, or up and up, or down and down. Notice that was the one-sided limit, negative infinity. If I gave you limit as x approaches 5, the two-sided limit, that's the one you'd say does not exist because we have no trend in y here. But we can find the trend in y with a one-sided limit at a vertical asymptote. And the technique I use is to just substitute in a value very close to the desired value.